Okay, so we're recording again. All right, so again, okay. Notice also, let me say this, that the line, the blue line, right, that slope is bigger, okay, and this line is more vertical. You know, it's closer to being vertical. It's steeper, if you will. That's better. And that's no coincidence either. The bigger the slope, the more vertical the line is. The closer it is to being vertical, the steeper the line is. And that's what's happening here. Okay, that's cool. Well, let's do another one similar to this. So in this case, as you can see, okay, here this one's a little bit different. Well, it's not terribly different, but notice the lines are passing through point 1, 2. The blue line is passing through 4, -1. So now the blue line is here, okay? And you know, again, we're just calculating slope. That's all I'm doing here. The green line is beneath it, okay? Good. All right, but you can see though how both lines pass through the point 1, 2, okay? Not only that, okay, this line here, you know, 4, -1, okay, the blue line's passing through that point. So for the slope, I did 2 minus -1 over 1 minus 4. And you want coordinates for the same point, you know, on top of each other, okay? On the same side of the minus signs, if that makes more sense. For the other coordinates, -1 and 4, right, they're on the right side. And basically what you get when you do this calculation, you get -1. And for the green line down here, it's similar, right? The only difference now is that instead of going through 4, -1, it's going through 4, -4. So essentially this -1 gets replaced by -4. Again, 2 minus -4 over 1 minus 4. That's what I'm doing. You could go the opposite way. That is, you could do -4 minus 2 over 4 minus 1. If you do the calculation correct, you'll get the same answer. So we have 2, right, and 1. They're from the same point. They're on top of each other. Okay. The other point, they're from the same point as well. See? Wonderful. Yahoo. And here we get 6 over -2, which is -2. Okay, well, what do you notice about these two lines? Well, for one thing, they both have a negative slope, right? Also, as you increase x, these lines are pointing down and to the right. In other words, the lines are falling, so to say. That's going to happen if it has a negative slope. If you increase x, meaning move to the right horizontally, like I'm doing with the laser pointer, the lines are falling. They're falling. Okay, they have negative slope. They're falling, meaning their height, right, gets more negative. That is, their y coordinates, excuse me, are getting more negative. You can see that from the points also. Notice if I increase x, the x coordinates, right? If we make our x coordinate bigger, the y coordinates get more negative. They get smaller. You know, the more negative you are, the smaller you are. See? That's happening here as well. We increase our x, the y coordinates are going to get smaller, the corresponding y coordinates. Not only that, they both have negative slope. The green line's slope is more negative. It's more negative. And it's more vertical. It's steeper than the blue line. It's steeper than the blue line. So in fact, the more negative you are, the slope is, the steeper it's going to be. I know that's a lot, so that's why I summarized it here. So I'm summarizing what I'm trying to say, that basically a line with a positive slope, okay, as you increase x, the line is going to rise. A line with a positive slope is going to rise as you increase x. Let me see if I can draw that quickly. That might help. Come on. So, see if I can do this. Okay. So I don't know how great a picture this is, but hopefully here you can see what I'm trying to illustrate, that the line with a positive slope, okay, that line is going to rise as x increases. That's what I'm trying to show here. And from the previous sketches, the larger the slope is, meaning the bigger it is, the more vertical the line is, the steeper it is. And 3 is, what am I doing? 3 is kind of similar. Namely, if instead the line is the slope is negative, well, what's going to happen here is that line's going to fall. Okay? As you move to the right, that line is going down, pointing down to the right. And the more negative it is, the more vertical, the more steeper the line is. Okay? So hopefully that makes sense what I'm saying. I really hope it does. Okay? Are there any questions? Remember, I can't see the chat, so if you have a question, use that hand raise feature, or just speak into your mic. Okay. Okay. All right. So now what we're going to do is this point slope form. Basically, what's happening here is this. We saw that if you have an equation in variables x and y, its graph is the collection of all solutions to the equation, which are ordered pairs. Okay? And a graph is really just a collection of plotted points in the plane. What I'm trying to do is say that lines are graphs of equations in two variables. Basically, every line has an equation in x and y in two variables. And to get an equation of the line, we need the slope and a point on that line. So I guess minimally, we need 2 points, because from 2 points, you get the slope, assuming the line's not vertical. So we can get an equation of any line if we know its slope and a point on that line. And one way of writing that equation is the point slope form, is in point slope form. And that's what I'm saying here. I mean, hopefully it makes sense what I'm trying to say. Basically, if you have a line whose slope, so we're assuming the line is not vertical, because non-vertical lines are the ones that have slope. If the slope is m, and we know it passes through this point, then an equation of that line can be written this way, which is called point slope form of the line. And what we mean is, if you were to graph this equation, meaning you were to sketch all the solutions that are to this equation, you would get this line, which has slope m and passes through that point. So as a quick example, right, the first line we found had slope 2. Well, not the first line, but one of the lines we saw. Well, using the slope and either of these points, we can get an equation of that line using this point slope form. And that's what I have here. So this 2 is the slope. Here for 1 and 2, that's a point on the line. You know, the x coordinate and the y coordinate of that point. That's if we're using this point. So the 1 is here, the 2 is here. Now, do we have to use this point? Well, you can see from what I wrote, no. We can use any point on that line. You know, here, I never said this x coordinate has to be 1. It could be any point on that line. So if I were to point 2, 4 instead, it's the same line, so the slope is the same. We would have this, as you can see. The slope, y minus the y coordinate, and we have x minus the x coordinate on the right. Okay, that's good. That's point slope form, okay? So why don't we consider an example? So let's say we wanted to sketch the line whose equation is this. Now we know this is a line. Now looking at the line, we can immediately see a point on that line. As I wrote here, we have 3, 1. I mean, yes, I wrote down, okay, if x is 3, that forces y to be 1, you know, from the equation. So in other words, this satisfies this is a solution of the equation. So this is on the line. But really, if you went back to the formal definition, right, it's really just by looking at the equation. Here's our x, here's our y coordinate. And x1 and y1 are numbers here. So in this case, they're 3 and 1. But we need another point on that line. Okay, no big deal. You could take x to be anything. I mean, I took x to be 4 for fun. And if x is 4, then in the equation we have y minus 1 is 5 times 4 minus 1, which of course is just 5. So y minus 1 is 5. That forces y to be 6. I mean, I didn't show the calculation, but I really hope you can see it now. So in other words, we just need 2 different points on the line. And then once we have those, we can connect them. I mean, 4, 6 is over here. 3, 1 is here. You know 2 different points on the line, you essentially can easily graph the line. I mean, I really hope that's making sense. Let me just stop the recording. Okay.